All right, let's get into it. Today, we are tackling one of the most critical responsibilities a senior cloud architect has: disaster recovery. And look, this isn't just about making backups. It's about orchestrating a whole symphony of services to make sure your business can survive a total catastrophe. So let's dive into the playbook for architecting real, actual resilience in Azure. So, let me start with a question, and be honest with yourself, it might make you a little uncomfortable. Think about your DR plan right now. Is it a living, breathing strategy that you've personally seen work with your own two eyes? Or is it just a document kind of gathering digital dust on a server somewhere? You know, that gap between having a plan and proving it works, that's where careers are made or broken. The first most crucial mindset shift we all have to make is moving from if a regional outage ever happens to when. It's just a matter of time. In this incredibly complex, interconnected world of the cloud, regional failures are, frankly, an inevitability. Our job as architects isn't to prevent every single failure. That's impossible, but to design a system that can absolutely withstand them. Okay, so how do we actually build that resilient system in Azure? Well, the good news is we have some incredibly powerful tools at our disposal. I like to think of these as the primary weapons in our resilience arsenal. Mastering them isn't just a good idea, it's pretty much non-negotiable if you want to build robust, fault-tolerant systems. Let's break down two really core concepts here. On one hand, you've got a backup. Think of it as a snapshot in time. It's fantastic for recovering from something like data corruption, but restoring from it, well, it can be slow. And that directly impacts your recovery time objective, or RTO. Replication, on the other hand, it's a live running copy. It gives you a much, much faster RTO, but it might not save you from data corruption if that bad data gets replicated. And that's where your recovery point objective, or RPO, comes into play. Basically, how much data can you actually afford to lose? Now, a real cornerstone of Azure's replication story is RAGRS. That's Read Access Geo-Redundant Storage. Now, this isn't just some passive copy of your data sitting on a shelf. The RA part is the key. It means your applications can actively read from that secondary copy during normal, everyday operations. I mean, this is a total game changer for building globally distributed, highly available applications. So for this explainer, we're going to focus our DR playbook on three of the most common and, frankly, most critical data services you'll find in almost any Azure environment: your core SQL databases, your SMB file shares, and, of course, the blob storage that's powering your data lakes. The principles we're about to cover, they apply directly to all three of these. All right, so we've talked about the what, but now we got to get to the most important and, honestly, the most often skipped part: the how. A DR plan is purely theoretical until you practice it. The goal here is to build muscle memory so that when the pressure is on and things are going sideways, you and your team can execute without even thinking about it. I really want you to let this sink in. It is one of the truest statements in our entire field. An untested DR strategy, it's not a strategy, it's a prayer. And let's be real, hope is not an effective mitigation plan when a whole region goes offline. So the crucial question is, how do you practice safely? And here is the pro tip. You never, ever, ever test your DR plan against your production environment. You spin up a totally separate, isolated environment, ideally in a different subscription altogether, and you perform your restore and validation there. This gives you a safe sandbox to find all the little problems and fix them without risking your live services.
Okay, picture this. The alarms are blaring. The primary Azure region is offline. Panic is starting to set in for everyone, but not for you. Why? Because you've practiced this. Let's walk through the high-level steps of what happens next.
So what's interesting is the first two steps aren't even technical. Step one is a business decision. Someone with authority has to get on the line and officially declare a disaster and give the green light to failover. Step two is verification. You have to confirm that the primary region is genuinely down, and this isn't just some local network blip. Only then do you move on. Now we get to the fun part: the actual technical execution. You kick off the storage account failover, which promotes that secondary RAGRS replica to become the new primary read-write endpoint. Then you trigger the failover for your Azure SQL auto failover group, making your Geo replica the new primary database. But wait, your work isn't done yet. The data might be live, but nobody can actually get to it. Step 5 is all about rerouting your users. You update your DNS or your traffic manager profiles to point to the application services in the new, now active secondary region. And finally, the most critical step of all, validation. You run a predefined set of tests to prove the application is 100% functional before you give the all clear. Now that simulation, it sounds pretty smooth, right? But let me tell you, the reality is, the very first time you run a test like this, you will find problems. And this is where the real work of an architect happens, turning that theory into a battle-tested reality. So let's talk about the wisdom we've gained from the trenches. Take a good look at this number, 75%. Just let that sit there for a second. What do you think that represents? It's a pretty stark figure. And it represents the cold, hard reality of untested plans. That's right. A staggering 75% of initial real-world DR tests reveal some kind of critical flaw, a flaw that would have caused the entire failover to completely fail. And this just perfectly illustrates why we test. We don't test to prove our plan is perfect. We test to find the flaws before a real disaster does it for us. So what kind of flaws are we talking about here? It's almost always the small things. I once saw a multi-million-dollar failover completely fail because of a single forgotten hard-coded connection string in an app. We also see things like forgotten firewall rules in the secondary region or out-of-sync secrets and keys. These are the little details that will absolutely sink your ship. So how do you turn this into a repeatable, actionable plan? Well, you start with a simple template, just like this one. You define specific test items like a database restore or a full application connectivity test. You define exactly what the expected outcome is. And most importantly, you define the frequency. This turns DR from a scary one-off project into a regular, disciplined practice. I want to leave you with one final thought here, and it's a big one. You can't just click a button in the Azure portal and make your application resilient. True resilience isn't a feature you configure. It's a culture you practice. A culture of proactive planning, of rigorous testing, and of continuous improvement. So my question back to you is, when's your next DR test?